Sir Edmund Whittaker, the mathematician who mapped electricity. Sir Edmund Taylor Whittaker stands as one of the most influential mathematical physicists of the last century. Yet, many people have never heard his name. His work sits on the foundations of electromagnetism, relativity, signal processing, and the philosophy of science. He didn't chase headlines, he quietly built the frameworks everyone else uses. Whittaker wasn't just a mathematician, he was a curator of the invisible architecture behind physics. While others focused on invention, Whittaker focused on understanding. The kind of understanding that unifies fields, bridges errors, and changes how entire disciplines tell their own story. This is why scientists still reference him today, because he wrote the blueprint for electricity's intellectual evolution. Origins. Born in 1873 in Southport, England, Whittaker grew up at a time when electricity was still a mystery and there reigned supreme, as there imagined, a medium of electromagnetic activity. Entering Trinity College placed him among the finest mathematical minds in Britain. At Cambridge, Whittaker excelled not just through raw intellect, but through his uncanny ability to see structure behind every subject he studied. While most students tried to master equations, Whittaker tried to understand where those equations came from and why they worked. That worldview would later enable him to connect centuries of electrical theory into a coherent, continuous narrative. The Royal Observatory. His work at the Royal Observatory sharpened his mathematical precision. Celestial mechanics required extreme accuracy. Tiny errors produced massive distortions, and taught him how interconnected physics forces were, and how geometric patterns underpin every form of motion. The observatory also exposed Whittaker to the practical side of scientific measurement. He saw how data, theory, and physical reality must constantly align for a theory to survive. This experience became crucial when he later analyzed historical theories of electricity. He could see why some survived and others collapsed, not through bias, but through rigorous lens of observed consistency. The Professor. From Dublin to Edinburgh, Whittaker grew into a world-class teacher. His lectures were famous for their clarity. He would take complex ideas in mathematics or physics and explain them with precision and poetry. His classroom became a launchpad for future physicists. Edinburgh became Whittaker's empire of thought. Over 3 decades, he built research groups, mentored young physicists, and modernized mathematical physics in Scotland. The environment he fostered produced breakthroughs in wave theory, relativity, and field mathematics. Generations of scientists indirectly carry his intellectual fingerprints. Electricity before electricity. Whittaker's historical research explored the era when electricity was imagined as ripples in the universal medium. He studied Faraday's intuitive field sketches, Maxwell's mathematical unification of electricity and magnetism, and Hertz's experimental conformation of waves. What fascinated Whittaker most was how these early scientists with modern equipment constructed their theories through sheer imagination and reasoning. He emphasized how the ether acted as an intellectual scaffold. Even though it later dissolved, the mathematics built atop it survived. For Whittaker, studying electricity meant studying the evolution of human thought itself. Historian of electromagnetism. Whittaker's masterpiece, A History of the Theories of Ether and Electricity, remains unmatched. It traces the conceptual journey from classical ether concepts through Maxwell, Lorentz, and the early relative era with detailed clarity. Whittaker's historical work mattered because he refused to oversimplify. He preserved nuance, showed how each scientist contributed a unique layer to the growing structure of electromagnetic theory. His volumes became a roadmap for modern physicists wanting to understand why our theories look the way they do, and which ideas were abandoned, adapted, and reborn under new names. Whittaker's mathematical contributions. Whittaker contributed directly to the mathematics used in electrical engineering. The Whittaker-Shannon interpolation formula is the core of digital sampling, and its potential function work remains vital to electrostatics and wave analysis. Beyond these, Whittaker created mathematical tools that bridged abstract theory and practical engineering. His function solved problems in quantum systems, electromagnetic boundaries, and wave propagation. Even in fields he never directly worked in, communications, acoustics, optics, his mathematics quietly operate behind the scenes. The philosopher of electricity. Whittaker believed that electricity revealed the deep architecture of reality. For him, its mathematical harmony reflected something fundamental, an underlying order, not a collection of coincidences. He argued that physics progresses not only simply through experiment, but through the discovery of deeper symmetries. Whittaker saw electricity as a window into the universe's geometric foundation, a universal language where fields, waves, and space-time echoed the same structural themes. His philosophical stance influenced generations in theoretical physicists. Honors and later life. Whittaker received widespread recognition. Knighthood honored his lifelong service to science, and his leadership roles within major scientific societies reflected his influence. Even after retirement, Whittaker continued writing, teaching, and advising. His later works explored connections between mathematics, physics, and metaphysics, showing that this curiosity never dimmed. His intellectual presence shaped the culture of scientific thought in Britain for decades. Enduring impact. Whittaker's legacy is embedded in the very structure of modern science. His historical analysis preserved the lineage of electrical thought, and his mathematic contributions remain essential. Today, researchers studying electromagnetism, relativity, wave physics, and signal theory inevitably encounter Whittaker's fingerprints. His work bridges the past and present, ensuring that scientific ideas aren't isolated events, but interconnected chapters in a larger cosmic narrative. He is, in many ways, the librarian of electricity's evolution. Closing. Sir Edmund Whittaker didn't shape electricity with machines or inventions, but by giving us the intellectual map that shows what electricity is. His work reminds us that science is not only about discovery, but about understanding. By tracing the ideas that built our modern world, Whittaker ensured that the story of electricity remains coherent, meaningful, and accessible. He turned the invisible into something we can follow, chapter by chapter.